Here is a very old problem. You're walking through an alleyway and in front of you there are two ladders. The two ladders are leaning diagonally across the alleyway, so the foot of each ladder is at the opposite wall. From your viewpoint, the ladders cross at a certain height. Let's call that height h. If the height of the wall on the left is a and the height of the wall on the right is b, can you give the height at which the ladders cross only using the values of a and b? This is apparently an ancient problem known as the cross ladders problem, and what we're here to do is prove that you can find the height by using the equation 1 over h equals 1 over a plus 1 over b. So let's see how we come up with this solution. Now I'm going to use a much simpler diagram to represent the walls and the crossing ladders. So on the left side is the length of the left wall, which is a, and on the right side is b, which is the height of the right wall. Now let's draw two diagonals that represent our ladders that pass from the foot of one wall to the top of the opposite wall. We can see that the ladders cross at a certain height, and we've given that height the value of h. And I'm just going to add one more thing to the structure, which is a line that's perpendicular to both a and b, and that passes through the point where the two ladders cross. This results in several triangles. Now let's remove one of these diagonals. This leaves only two triangles. We know that the green line is perpendicular to both of the lines A and B, and that means that these two triangles contain right angles, and we can see that the point where these two triangles touch is actually the intersect point of one of the diagonals and this new perpendicular we just drew. But we know that opposite angles on an intersect are equal, which means that these two angles are the same. And so what we have here is two triangles that have two of the same angles. They both have right angles and they both have the purple angle. And that means the other angle in both triangles must be equal, and because these triangles have all of the same angles, they must be similar triangles. If we introduce the other diagonal, we'll get a similar result. But let's remove the first diagonal and those two angles to make things a little bit more clear visually. We have two other triangles now, and both of these must have a right angle because they both have an angle that's formed by the perpendicular and the vertical line. And again, the points where the triangles touch are where the diagonal and the perpendicular intersect, so the opposite angles on that intersect must be equal, and so the remaining angles in these triangles must be identical, and so that means these two triangles are similar. Now let's bring back the first diagonal and its angles, and we have two pairs of similar triangles. The two triangles with blue angles are similar, and the two triangles with lilac angles are similar. Since the cross points of these two ladders intersect with the perpendicular, I'm going to label the perpendicular on each side of the intersect. The left side is u and the right side is v. And I'm also going to label the outer edges of these four triangles. Well, the length of the outer edges of the bottom two triangles must be h, because they're the height of the perpendicular from the ground. On the right hand side, the sum of the two edges is b, so if the length of the lower edge is h, the length of the upper edge must be b minus h. And the sum of the two left edges is a, and if the length of the lower edge is h, then the length of the upper edge must be a minus h. And now we can show why 1 over h equals 1 over a plus 1 over b. Now we know that when you have two similar triangles, if you divide the edge of one triangle by its corresponding edge in the other triangle, and you repeat that for the other two edges and their corresponding edges, you'll get the same value for all three divisions. And if we do those divisions on these two pairs of similar triangles, we get an interesting result. Let's begin with the corresponding edges of the triangle with blue angles. The vertical edges of both triangles are the shortest edges and correspond to each other, and if you divide the bigger edge by the smaller edge, we get h over a minus h. But the bases of the triangles are the edges v and u, and if we divide the longer base edge by the shorter base edge, we get v over u. And these are both edges of the larger triangle divided by the corresponding edges, so these values must be equal. And now if we do the same thing with the other two similar triangles, dividing the larger outer edge by the smaller outer edge, we get b minus h divided by h. The base angles of these triangles are also v and u, so if we divide the larger base angle by the smaller base angle, we get v divided by u, and these two must be equal to each other because they are just the division of corresponding edges. But that must mean that h over a minus h, which equals v over u, must be the same as b minus h over h. And if we use cross multiplication on both denominators, that means that h squared equals a minus h times b minus h. Let's give ourselves some more writing room. And if we expand those brackets, we get that h squared must be equal to a times b minus ah minus bh. And the two negative h's multiplied, that gives us plus h squared. We have h squared on both sides, so they cancel. And that gives us that 0 equals a times b minus ah minus bh. If we add the negative numbers to both sides, then we get ah plus bh equals ab. We can factor out the h's on the left hand side, so that gives us that h multiplied by a plus b equals ab. And if we divide both sides by a plus b, we get that h equals ab divided by a plus b. If we take 1 over h, that must be equal to a plus b over ab, but that can be split into two fractions in this way: a over a b plus b over a b. The a's cancel on the first number, leaving us 1 over b, and the b's cancel on the second number, leaving us 1 over a. So 1 over h equals 1 over b plus 1 over a, or 1 over a plus 1 over b. And that's exactly what we're aiming for. We proved that the height can be given by 1 over h equals 1 over a plus 1 over b. And so for the crossed ladders problem, with the two walls of height a and b, we can find the height at which the ladders cross with the equation 1 over h equals 1 over a plus 1 over b. Well, that's it for now. Thanks for watching.